Welcome back to the session. So, in additive manufacturing, we are studying module 4, that is nanomaterials characterization. And today's topic is optical microscopy and scanning electron microscopy. Nanomaterial characterization in that, so first we must know about the characterization. So the characterization, the techniques. The characterization of nanomaterials involve determining the structural, optical, electrical, magnetic and mechanical properties depending on their applications. Structural characterization involves determining the morphology, that is nothing but shape and size of the nanomaterials, and arrangement of the atoms, that is their crystal structure, and also material composition of nanomaterials. And the microscopy techniques, these microscopy techniques have been around for many decades and are always improving. The field itself has had to improve because the samples being analyzed have been getting smaller and smaller, especially since nanomaterials have emerged into many areas of the science. So these microscopy techniques are always improving. Then the first of the kind in the microscopy techniques is optical microscopy. So optical microscopes are found in every laboratory and are used to image a wide variety of samples, and they are also known as light microscopes. These microscopes use light to illuminate a sample and vary in complexity depending on the type. In short, photons of light are passed through the sample to illuminate it, and a set of lenses are used to enlarge the sample as per the objective magnification. Some microscopes use compound lenses to magnify the sample, but anyone who has used these microscopes knows that the magnification is not very high. The optical microscopes, they are ideal for observing samples that you can see with the naked eye, but in more detail, as well as the micron sized materials. However, they don't have the ability to observe nanostructured materials in great amount. As a magnification is possible up to 1000 times, and the very best resolution is possible is about the size about 200 nanometer. Actually, this 200 nanometer, this is more than the dimensions of most of the nanomaterials. So while the nanomaterial characterization is considered, this optical microscopy is not of much importance. And next is the next development in the microscopy is electron microscopy. So electron microscopy encompasses a number of techniques, but the most notable are scanning electron microscopy and transition electron microscopy. The electron microscopy techniques are high powered and high resolution microscopy techniques that use electrons instead of photons to analyze a sample. The electron microscope techniques have become some of the most widely used microscopy techniques. Along with the atomic force microscopy, these electron microscope techniques have become most widely used especially for imaging and analyzing a nanomaterial is concerned. These electron microscope methods can be used on all nanomaterial types, and the transmission electron microscopy is specially designed for the nanoscale as it struggles to provide a high quality image if the sample is more than 500 nanometer thick. In both SEM, that is scanning electron microscopy, and transmission electron microscopy, an electron gun fires the electrons through a series of optics, and this focuses the electrons towards the nanomaterial. So that we'll study in detail about these things, the optical microscopy as well as scanning electron microscopy in this today's session. So this is the optical microscopy, the principle. So it is a type of microscope which uses visible light and a system of lenses to magnify the images of small samples. So image from an optical microscope can be captured by normal light sensitive cameras to generate a micrograph, and the function is to create a magnified image of a specimen. Consists of three basic functions of obtaining a clear sharp image, changing a magnification, and bringing into focus. So it creates a magnified image by combining an objective lens and making an inverted real image, and magnifies the image further more with an eyepiece to allow the user to observe it by naked eye. And this is the actual image of optical microscope, so showing the place where the sample is to be kept, and the light from that sample, it is passed through a magnifying lenses, and it is seen through the eyepiece from the top. And these optical microscopes, the applications involve microelectronics and medical diagnosis, in biotechnology, and as well as nanophysics. And the advantages of optical microscopy are medium cost, simple devices, because these optical microscopes are simple devices having a medium cost, and these are fast and adaptable to all the samples. And there are certain disadvantages also. These optical microscopes have low resolution, and high level magnification is not possible with these optical microscopes. And next we'll study from the electron microscopes. We are studying now about scanning electron microscopy. So scanning electron microscopy is a special type of electron microscope, and in this the images are produced by scanning the surface with a focused beam of electrons. The electrons interact with atoms of the sample, resulting various signals containing information about surface topography, the composition, and other properties. Electron beam is scanned in a raster scan pattern, and its resolution is less than 1 nanometer. So it works in a wide range of pressure and temperature conditions. And this is the scanning electron microscope, how it works. So at the top we can see the electron beam. So the generation or the production of the electron beam that passes through the objective aperture, and that beam becomes thin, and from then onwards it is passed through the objective lens, and it falls on the sample, and from that the secondary electrons which are scattered, so that will be captured by the detector. So that will get from the next image, next figure. So this figure, it clearly shows the principle of working of scanning electron microscope. So at the top we can see the electron gun, the anode, and the magnetic, the lens, and then the scanning coils, the electron detector, then the stage where the sample or specimen which is placed. From the electron gun, the electrons are ejected and they are passed through the lenses, and then it falls on the specimen or the sample, and the secondary electrons which are scattered from the sample, they are captured by the secondary electron detector, and from then it is connected to a raster scan image processor. Then the image of the specimen, it can be obtained on the screen. So here how the scanning electron microscope works, its principle, it is like when the beam of electrons strikes the surface of the specimen and interacts with the atoms of the sample, the signals in the form of secondary electrons, back scattered electrons, and characteristic X-rays are generated that contain information about the the sample's the surface topography and its composition, etc. Thus, scanning electron microscope can produce very high resolution images of a surface. It may reveal the details about 1 to 5 nanometer in size in its primary detection mode. And secondary electron imaging, so in the characteristic X-rays are the second most common imaging mode for an SEM. So these characteristic X-rays are used to identify the elemental composition of the sample by a technique known as energy dispersive X-ray. So backscattered electrons that come from the sample may also be used to form an image So these backscattered electrons images are often used in the analysis of analytical SEM along with the spectrum made from the characteristic X-rays. So this scanning electron microscope, it requires that the specimens should be conductive for the electron beam to scan the surface, and that the electrons have a path to ground for the conventional imaging. And non-conductive solid specimens are generally coated with a layer of conductive material. And its applications involves the SEM. It shows very detailed three-dimensional images as much as high magnifications up to 3 lakh times, as compared to these light microscopes which are about having the magnification about 10,000 times. But as the images are created without the light waves, they are usually the color is black and white. And the surface structure of the polymer composites, that polymer nanocomposites, the fracture surfaces, nanofibers, nanoparticles, and nano coatings can be imaged through this scanning electron microscope. So these are about the applications of scanning electron microscope. Then about the advantages and disadvantages of the scanning electron microscope. So the advantages are these can be used for the wide array of applications, and these can gather versatile information for gathering. So these can be used for gathering versatile information, and also these are user friendly operation. Then generation of the data will be in the digital form. It can produce the data in a digital form. Minimum preparation actions, so it will not be requiring a lot of preparations. Then the speed, it is ultra speed capacity. The speed of the operation is higher. And about the disadvantages, these are a little bit expensive, and these are the sizes are large, and sensitivity towards the electric, magnetic, or vibration interference, because these are using the electron beam. So these are sensitive towards the electric or magnetic or the vibration interferences. So a requirement of special training. So to handle the equipment, it requires some special training, and limitation to solid inorganic samples. So these are the some of the disadvantages, or can be called as the limitations of scanning electron microscopes. So this is all about optical microscope and scanning electron microscope. And thank you.